Well, sorry about that. My phone died there. So we're going to resume with this question. When I got cut off, I had said the intercepts were 0, 6, and it's actually 6, 0. So I misspoke there. Intercepts are 6, 0 and 2, 0. So we'll be able to put that in intercept form. What we don't know is what the A is. Now, some of you might be able to go, oh, look, I can see it's over 2, up 2, and figure out what A is. That's okay. There's an algebraic method to do this. So A is something we don't yet know, but we do know that if the intercepts are 6 and 2, then our intercept form should look like this. Because 6 would go in there, and that would make that 0, so I'd have 0 as my y. Or 2 would go in there, and it would make that 0. So that's why we take the intercepts and put them in intercept form. We also have a vertex here of 4, negative 4. And that's important for us to find A. So a couple different methods to find A. One of them would be to say I can identify points here and say, oh, this is over 4 and up 2, 4, 6, 8. So normally I go over 4 and up 16. So then how would we get to 8? And you could say, well, A must equal 1/2. That's fine. The other way would be to use our vertex, and this is similar to what we did up here in number 6. Use our vertex for our x and y. So we have our equation except for A. Let's put everything in except A, and then we can solve for A. So y is negative 4. A is the thing we don't yet know. X is 4 minus 6. X is 4, and then minus 2. And now I have, in my parentheses, numbers that we can calculate. So I have 4 minus 6 and 4 minus 2. So that's 4 minus 6 is negative 2. 4 minus 2 is 2. So I have A is negative 2 and 2. Wait a second, what is going on here? I know what I did. All right, well, Mr. Woodward makes a mistake. Not an unusual occurrence, I am aware. Look at my scale here, right? So it's not over 4 and up 8. It's actually over 4 and up 1, 2, 3, 4. So, got to be careful of that grid. So A is not equal to 1/2, right? A is equal to 1. So my equation is y equals the A I know, 1. You actually don't have to put the 1 because 1 times anything is itself, but so, be careful when you're measuring something that are you paying attention to the scale? Because I didn't, and I almost made a mistake, and my algebra saved me. I was like, oh, good, I didn't make that mistake. Because I was looking here, and I went, wait a minute, that's not going to give me 1/2. What happened? Oh, that's what happened. All right, last one. Sheila's fighting a fire from a ladder. So we've got a scenario that gives us this function, and we have to graph the function. Before you freak out, notice that we had a function in standard form here and we had to graph it. So it's really the same process. It's just a matter of applying it and answering a couple questions that show how do we understand how these two relate. So let's get to work on this. To graph, I need to find the vertex. Right? That should be something that you just say, look, I know if I have to graph, I have to have the vertex. So how do we find the vertex? This is our negative b over 2a. So a equals negative 0.25, b equals 2. So this is negative 2 over 2 times negative 0.25. Okay, so 2 times 0.25 is 0.5, so that's negative 2 over negative 0.5. So I've got 2 divided by 0.5 is 4. So that's my x value for my vertex. What's my y value? F of x, or y, equals negative 0.25 times 4 squared plus 2 times 4 plus 5. So this is negative 0.25 times 16 plus 8 plus 5. So I've got negative 4 plus 8 plus 5, or 9. So I've got a vertex of 4, 1, 2, 3, 4, 9. All right. A equals negative 0.25. So instead of going over 1 and up 1, I'm going over 1 and down 0.25. Instead of going over 2 and down and up 1, 2, 3, 4, I'm getting over and down 1, and then over 3 and down negative 0.25, so that's going to be 2.25. That's a little bit tricky. If you get up a lot of decimals, you find out, just say, oh, I'm not going to worry about 3. I'm going to go, normally I go over 4 and up 16. So 16, but times negative 0.25, it's going to give me negative 4. So that means I go down 1, 2, 3, 4. Over 4, down 4. All right, so our vertex is negative 9. So at what distance does the water reach its maximum height? Vertex is 4, 9. 9 feet, right? I guess I didn't say feet. So I didn't say how much it is. So 9 meters, 9 feet. But that's our maximum height right there. Now, how far does the water travel? So we're saying, how far does it travel before it hits the ground? Well, this requires a little bit of either additional math or guesswork. So the additional math will confirm. If I go over 4, normally I go up 16. Over 5 would be up 25. Over 6 would be up 36. So remember what my A does is my A says multiply the normal by A, and that'll give you your new one. So 36 times negative 0.25 is negative 9. So I go down 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how I know for sure that I'm at this point 10, 0. And that is why I can answer this question and say, how far does the water travel before hitting the ground? Here's the water, and it travels how far? 10 feet. Okay, from 0 feet to 10 feet. All right, there's your rest of your review. I commend you to remember to use the pause button, or if you didn't, to grab a clean copy from email and try it again with just you, yourself, and a calculator. And good luck on your test.